Huzzah! Hello. I am back. I am back from the other side of the internet. Tonight, we're going to just work on the proto. I had no time to work on it, so I figured the hell with it. I really want to work on it. Let's work on it live. So that's what we're gonna do tonight. We're just gonna develop, see what we can figure out. Right now, I took the existing code we had from last time, and I just connected the other screen. I haven't told the code yet that there's another screen, and interestingly enough, it has done some interesting things. So before I even open the compiler, let me show you what's going on. Nothing, because I'm zoomed in too far. Oh, hey, I'm it. Okay, now that I got the camera zoomed out, let me show you what's going on here. So what we do need to figure out is when the faces are going to be installed in the proto head, they can't be in the same direction. So right now we're getting the same face twice, and for some reason I've got these two additional pixels turned on. Now I did switch these boards and the same behavior will occur. To showcase on the back here what's going on, we've got the data cable plugged in here that ties into the microcontroller. It's then daisy chained to the second one, and then it just shares one harness to power both displays. So right now we're using 0.14 amp at 3.7 volts. So this is great for one of the two, but these are going to be in a fashion that's more like this. So since it's going to be in a cheese wedge type of configuration, more like this is great for what would be our right panel, but that's no good for the other side, because right now the image, with the way that the screen is positioned, it needs to be mirrored. It needs to be opposite, so that we can have a consistent face depending on which side of the proto you're looking at. So what we're going to do tonight is we're going to figure out how to declare the screen to be side by side, and more importantly figure out how to mirror this side. I'm hoping that once we declare that these two green pixels that are currently on will shut off, because again, I don't have anything in the code right now that is telling them to be on. But I also did not inform the code there's a second display connected here. So interestingly enough, before we even do anything, the second one does in fact work. Not exactly as intended, but pretty close. So that's what we have right now. And we're gonna run with that as we figure out our next move here this evening. So yeah, that's where we're at right now. And we're just going to open up the code. We'll take a look at the previous example, and then Adafruit, who made the Proto Matter library that we're currently using, has an example for using more than one display. We're going to see if that's helpful. If it is, we'll probably bounce off of that. And then if there's time, I don't know how long this is going to run tonight, because I have other things unfortunately I do need to work on. We're going to see if we can maybe combine some of what we learned into the actual main project, because we have to take what we learned about controlling the fan and bake that into the main code. And also, once we figure out these two major displays, we want to incorporate the faces we've made thus far in the code to make it appear in that cheese wedge formation into the main project. After that's done, the major bulk of the project is done. I still want to incorporate the microphone, so what's probably going to happen, because I want to have the mouth animation kind of like I do here, what I'll probably do is I'll incorporate it and it'll get installed in the head. It'll get connected to one of those analog headers, and then as time moves forward, I could hopefully work on the code while also working on the build. because incorporating the microphone should be pretty straightforward. It needs ground and signal. So tie it to the microcontroller, include it in the head. The board's really small. So that's kind of the angle. But I want to, because we still have to get the battery situated. That's going to power all this stuff. So I want to just push along to get this functional enough that we know what we're working with. And then we can work on building and proceeding to tinker with the code as we move forward. Because I do really want to get this put together. I'm probably going to miss the upcoming convention I want to wear this at, but that's okay. I told myself this is a very large project and it's going to take time since there's no physical build yet of the plastics or the fur or the learning of the sewing. I know some sewing, but I don't know if those skills will be enough just yet. So more learning is going to have to come on the horizon on stuff that I'm not super familiar with, but that's any project. So we're going to dive into the code tonight and see what we can do. So without further ado, let's get everything open here and pivot. Okay, so I kid not when I say ground up. We're going to get into here. And then in our experimental code, we had the... I'm gonna be honest, I don't remember which one I opened last. Let's see, sort by date. Adafruit Proto Matter example was on the 24th. So that's gonna be the most recent. Right there. That should be our most recent. Now I don't want to modify that one, because that one is our good working example. I'm gonna make a copy of it though. Now the next thing that has to happen here is the folder has to name the executable name, or the code won't run. I really exceptionally cannot stand Windows 11. What a crappy operating system when it comes to the renames. And I hate it when the file explorer just doesn't update, so that now you're no longer working on an active copy, you're working on a temporary ghost icon instead of the actual thing you're trying to rename. Microsoft needs to fix this. This is so unacceptable, to just being able to just rename files and folders. I've seen this way too often, and I'm not here for it. It's frustrating. Alright, so we're going to call this the Proto Matter, and we'll just do to screen. And then we're going to what the heck happened here? I don't know what the heck happened there. Looks like I doubled up on folders somehow. That's okay. Okay, so right now this is just going to open up a new copy of our code so that I don't damage what we've learned thus far. Okay, so we've got our matrix portal selected. What's going to be incredibly important and relevant to what we're doing tonight is having all of these pins in their definitions in the correct order. Now, part of the reason I wanted to open this is because that is in fact the order of said pins. And then we pass over to the object, and then somewhere along the way here. Nope, I opened the wrong one. Shoot. This is the basic example, not the one I put together. That's okay, we'll find it. I'll delete this one and make another one. Oh, hi Porsche, welcome on in. So, that's a lie. So then, was it this one? I'm just gonna look first before I think it was, because I think I made a separate file for that. Let me just look first. Yes, this is the one I meant to make a copy of. Okay, good. I'm gonna close this. And then we're going to copy and paste said folder I'm gonna refresh the screen so that I can rename the goofy thing. Okay. Alright. So we'll just call this V2. I don't know if I'll have to relink that other document, the actual faces file, right here. We'll see what happens when I open it. How does it go? It goes okay. I've been hilariously levels of busy. In my next 2 weeks, I'm going to be even more so. So we're doing some live development tonight because I really want to work on the proto, and I have time tonight, and here we are. So we're doing the thing because I want to work on this desperately. All right, cool. So this is pointing to the faces file, which is in the same folder. So real quick, I'm just going to quick verify. After I select the board, like a smart goober. Felt. That's fair. How you doing, Porsche? I haven't heard from you in a while. You doing okay, buddy? Actually, speaking of which, I've been making out with the camper. The last I heard from you, the bed support gave out on you. You're here. That's valid. Hopefully, you're able to get the bed thing situated because that's a tough roll when things break like that. Oh, excuse me. Oh, yeah. No, it's too early for that. We have stuff to do. No yawn. No yawn. Only no sad. We don't do sad yawns here. It's a pine. Hello. Bed got fixed. Oh, good. I'm glad to hear that you got that sorted. All right. So I have successfully copied this. So now that I can start playing with this one. Now, what I have to see here is the objects that we need to play with. Brinko bro with dots, but no money right to act. Oh, I'm sorry to hear that. That's not easy. Alright, so our definition for the matrix is up here. Yeah, okay. So I know that we have to modify this because this first item is the width. So I know that we have to double that. But as for the rest of this, I'm not sure. So what we're going to do now is we're going to open up the other example provided by Adafruit. Hopefully it's using the same library. I hope so. And then we'll see if we can figure out how to make multiple faces, with the second one being mirrored, so that we can have our cheese wedge that will be installed inside of the head. So at least goes the theory. The quick little doodles that we did to make the faces that we have right now are not going to be the end all be all, but it's at least something for us to play with, and I can get an idea of how much space it takes up on the microcontroller. So we'll see what we can do with that. Okay, let me save that really quick. Ooh, a D&D campaign, that's fun. You have a character sheet in mind, or is that something you'll be making on the fly? Take all the space. Yeah, no kidding. Yeah, I gotta remember where it is. I want to say it was an example of the library itself. Yes, I did. I remembered a thing. All right, good. And then we want the tiled example. I think is the one that is what she referred to it as. I hope. I pray. All right, the proto gets to read. Tiled proto matter library example sketch demonstrates use of multiple RGB LED matrices as a single larger drawing surface. This example is written for 2 of the 64x32 matrices. Yay, that's what I have. That's helpful. But can be adapted to others. If using Matrix Portal, larger multi-panel tiling like this should be powered from a separate 5V display, which is what we're doing right now, not the USB port. This example works okay because the graphics are minimal, but obviously we wouldn't want to do that further, which again, we're not going to. Samurai or Ronin? D&D handbook. Alright, fair enough. I had a group of people that wanted to play D&D, and I ended up getting my hands on the books, but then it just, nothing ever became of it. And with my time reaching closer and closer to the absolute zero, I would love to, but I don't have the time to put together a campaign myself. I also don't have the time to be a part of a campaign, so I love the idea, but yeah, no, that's tough gig. But by all means, Porsche, I hope you enjoy yourself if you do end up getting to pull that off. That sounds like fun. It's fun to fall into a story like that. Okay, so from what I remember, she's got a bazillion different definitions, so I can ignore all of these. And what I want to see is the definition for this thing right here. All right, so the width of the matrices, if tiled horizontally, which mine are technically portrait. I think that's the number I'm gonna duplicate by 2. Yeah, I hope you enjoy yourself. That should be fun. The bit depth between 1 to 6. Number of matrices chains, array of 6 RGB pins for each. Number of address pins, height is inferred. Clock latch and OE, false, it's fine. No double buffering here. See double buffering example, it's fine. 2 rows in serpentine path. I don't know what that means, but that's okay for right now. Alright, so then... Since there's nothing more... Okay, so this is really a very straightforward example. Alright, listen, I know the code's kind of haunted, okay? I can admit to that. It kind of looks haunted. I feel haunted. Alright, we're just gonna start playing with numbers and we're gonna see what happens. Cause I don't know, man. It looks similar. It looks really similar. So the thing that should technically be different is this definition. So if I compare that to the one we have over here, does it need a coconut? I don't know. That's a good question. We need to compare that to this. And what kills me is that mine are side by side, the width. So the width is going to be double. Now my bit depth, I wanted a less deep. Do I know the joke? No, I didn't immediately realize that was referring to something. There's a good chance I could know what it meant if I saw the thing. I am mostly made of dad jokes, so if it was one of those, I'm a little sad I missed. I'm a little sad I missed that one if it whizzed over my head. You know, so it goes. Alright, so I'm gonna keep that value the same, and then 1, 4. I am blown away right now that the definition of this didn't change in the tiled example. Right, and then we're just drawing. After drawing, a show call is required, and there's nothing in the loop. Of course not. An unknown random coconut PNG in the code of TF2. Oh yeah, I do remember hearing about that. And no one knows why the game will in fact break if you remove it. I do recall hearing something about that. Honestly, that's kind of what this feels like. I'm gonna play with some numbers, and we're gonna see what bad things occur to the stuff sitting on my workbench. I'm probably gonna be I'm gonna be deep in it tonight, I'm sure. Well, let's start playing with some stuff. So 64 times 2 is gonna be 128. So we're gonna bump that up to 128. I'm gonna change nothing additional. I do know that the other screen is gonna need to be mirrored. I don't know how to do that yet, but let's just push that in and see what happens. So I switch back to the cameras. I don't know if this is going to stretch what I've given it or if one of them is going to turn off. We'll see here in a minute. It's programming, it's uploading, it's thinking, and I'm kind of hoping that, you know, something preferable will happen. Okay, well, that answers that question. And that's kind of what I thought was going to happen. The second display is off. Now the trick here, it's like fully off. I mean, is that the first one or second one? Which one am I looking at here? Interesting. Okay. So the second in command, which is this one, which is daisy chained off of the first one, is where the main image went. It's all the way to the left. That's interesting. Okay, so all right, so we're making something. I don't necessarily know if I would consider this progress, but something has occurred. Because I think what let me get over there. I think what I needed to have happen is I needed to just invert the other display, but now knowing that it has shifted, right? Because I need it to be this way. This is the way it's going to be installed in the head. Why is my camera turned off? It's guys, are you still there? Did stream crash? Or did my camera just wig out? Okay, the camera crashed. Hang on a minute. I'm moving. Oh, good. Thank you for letting me know you're still there. I don't know what the hell happened here. Let's see if I can reactivate the source. That's better. I have picture. I was typing a paragraph. Now you're totally fine. I'm in the middle of talking here, and I update the thing. All right, let's yes. Okay, things move again. Fantastic. Okay, so this is what has occurred. Instead of having two pictures, I have one proto face and now a blank display. What I didn't anticipate is that I told the code that the full width of what we're doing right now is this way, because the width is 128 pixels from the left all the way to the right. So the code now believes this to be one long display, just like this. Now the issue here is twofold, because I need it to be installed like this, like a cheese wedge. Shoot, this was the correct orientation for the panel that's off. And this one is still backwards. So I now need to figure out how to get the picture on this display and mirror this one. So that's interesting. Oh God. All right. So what we know, what do we know? What do we know? That's a good question. What we know. Oh no. Oh God. All right, so we know that we could still work with the same file, right? But what we're dealing with is a mountain of shift registers here. That's what makes these things work. So what we need to do is we need to indicate that I need to produce this image twice. In the first instance of it displaying has to be mirrored. So let's see if we can figure out how to mirror this one, and then hopefully we can figure out how to make it appear on the other one. I hope. I pray. I knew it wasn't going to be easy. I can confirm it does get worse. That's coding in a nutshell, though. It gets a lot worse before it gets better. Truthfully, though, it's fine. I was a little suspicious that it might do something like that. I'm gonna be real, I wasn't entirely sure what it was gonna do, but that's kind of why I changed the value to see what would happen. So, all right, well, now we get to get creative. I think this. Porsche, I live by those words. The code doesn't work. I don't know why. The code works. I don't know why, and it kind of makes me a little angry. Yeah, it's kind of where we're at sometimes. Tonight don't feel no different. It's just kind of where we're at. Okay, so The way I initially thought this was going to work is different now, but I still think I might have this figured out. So I think that right now that was all we needed to do to this, was just change this one value to be twice the width. So now it knows that there's an entire length of display. Now the trick here is going to be twofold, because the very first thing it gives me in this draw bitmap is the shift on the X and the Y coordinates of where we are, to be on the very first display, which is the first in the daisy chain, or technically, no, hang on. No, it's the first daisy chain to display, but it's the second one that's physically connected. So it's gonna align left. So what we need to do is we need to see if this draw bitmap directly supports mirroring the values, because if I could do that, then I could just reuse the same block of code to draw both sides of the head. Because if I have to create an additional bitmap for the mirrored face, which I could do, that's going to take twice the amount of space than if I could just mirror it. And I should be able to use the offsets to indicate draw this a second time just as it is, but just offset by exactly one screen's worth of code. So let's figure out if we could just flip the face we have, and I think I've got it figured out. Assuming we can figure out how to mirror the first one. Trust me, Porsche, I feel that on the inside too. Because I'm flying by the seat of my pants tonight, okay? I have no notes. I have no emotional support tabs open right now. I normally have, I'm usually like 20 gigs deep in just Firefox tabs. I don't have any of that open. So we're just gonna stockpile resources until we figure this out. As I want to figure this out. I didn't quite get what I thought I would, but that's okay. So the next thing I want to see here now is if we can find some documentation on draw bitmap. So now, because unfortunately I can't exactly trust the internet, I do have to do the research out of camera view. I apologize, but this is for the safety of the stream, the channel, and my viewers. I will not put raw Google results on stream. I don't do that here. Alright, let's see here. Let's see if we can find something. Huh, okay, I might have to run that through something before I can mirror it. So it looks like I may be stuck having to do the flip myself. Minimal example using protomatter. Well, that's exciting. Create the protomatter object. Alright, the bit depth, which is fine. The number of matrices, channels, and parallels almost always be 1, but the library could conceivably support up to 5.
if the hardware driving it is set up precisely just so. That's fun. Alright, so I'm not really terribly concerned about refresh rate right now. I do want to try the sand demo though. I want that to be a part of the project, and since it's just some math, as long as it fits on the project, we're gonna have that, because that'll be a super cool thing to do at raves. You'll see what I mean, because I want that to be a part of this project. It's really cool looking. One amazing thing at a time. We're gonna get this figured out. Let's see here. Let's see how we do this. Yeah, so it looks like Adafruit's example doesn't directly support what I'm attempting to accomplish, which that doesn't necessarily surprise me. Alright, so I have a bitmap. I want to mirror it. So let's see how we manually do that. So let's see. So let's what did I store these as? Chars. It's a bunch of unsigned chars. That's an LED array. Let's see. Need to implement the solution manually. Off the start from bottom row to top row. Yep, that's actually accurate to what we're doing. Alright, let's see what we have here. You have a 4-bit bitmap. Hey, welcome back. I am going to go quiet on and off here while I'm reading through documentation. I really do think that we can get this flipped without needing to generate a mirrored bitmap. I really would rather not do that if I don't have to. But that's going to involve figuring out how to flip this without losing my mind in the process. Carve bitmap image into its negative, which may be what I'm trying to do. Wording's a little funny on this.
Oh, I'm intoxicated. I got a legend on the way. I'm falling for you, baby. What can I do to make you stay? The bassline's taking over. We've come too far to turn around.
Change the Q image to an array of chars. And afterwards, the pointers.
And let my feet not touch the ground.
Yeah.
Cause I'm in a daze and you're driving me crazy. Please can you stay even just for the night? I'm losing my way, but don't try to contain me. Cause I'm still running wild. Cause I'm in a daze and you're driving me crazy.
Mirror image of a character. Alright, let's see if this is useful. Program needs to print the mirror image of a letter that's input. All letters will be in uppercase. That's not quite what I want to do. Let's see. Or rotating a bit image that might be closer to where I'm trying to go. Can't seem to figure it out. How to rotate a bitmap, only move it horizontally and vertically on the XY axis, right? Because that's where I'm at, but I need to mirror it. So what do we do? It's the principle of bitmap manipulation rotation function, which can be adapted to your display, which is what I'm trying to do. Rotate and drop bitmap function. I don't think it's going to be a part of the library though. Please can you stay even just for the night? I'm losing my way, but don't try to contain me, cause I'm still running wild. Cause I'm in a daze and you're driving me crazy. Please can you stay even just for the night? I'm losing my way, but don't try to contain me, cause I'm still running wild. Take a pixel from the mirror, calculate the position. The mirror still contains the unrotated image. One approach gives you a permanent 15-degree change, the other is better for animation. The library loads the image. Pixel array buffer provides the library's methods. Implement mirroring logic. Use code similar to the C-based logic below. Swap the pixel's position horizontally. Okay. That's adorable. Video with the screen displays, you should be able to get this part. Boy, every time I want to do.
gonna make you move. Getting ready for the weekend. Make our way into the club. Time to get this party started. People moving all around the floor. We don't wanna stop, give us some more. You got to move to get down. Just move your feet to the sound. Me and my girls, we are down.
This is not what I wanted to be doing. Brr. Kills me when I find something I think might be relevant, and then it's like, JK, you're full of giggles. Oh, the GFX graphics library. Let me see, is that something that's in the project right now? It isn't in this example, but I feel like it is in the rest of the stuff. Let me see if it's possible to manipulate it with the GFX library. Maybe. There's potential in it. Because if I can potentially flip it and then feed it into the function, that would be better. I'd have to do it on the fly though every time, which would take up a little bit more RAM but less storage, which the trade-off might be worth it. Only on microcontrollers with considerable RAM, like the Adafruit M0 and M4 boards or ESP32. Small devices don't have a good time. Okay. Hit the queen to the same document. Sad face. Well, this is loading an actual image, which I don't really need to do. Interested in reducing flicker because this thing refreshes at 200 frames a second, which is a surprisingly decent refresh rate for a device that has very few in the the pixel space for a smooth transition. That's our buffer. Alright, before I fall too far down to a hole right now, I do want to try the other aspect of this that I think is going to work. So I'm under the impression that all we have to do to make the face appear on the first display in the correct order is going to be to adjust our X and Y offset to more or less just push the image onto the other display. And then once we figure out the inversion, these two should stay zeros. So let's try that. We're going to do a LED array. Right, now obviously we would have to modify and have more than one of these statements to do that, but that's okay. I just want to at least attempt to modify the void setup here. So right now, if we look at what we have, over here, we have the first display is currently off, and then we have the second display that's currently on. So what we're going to do is we're going to try to shift it to make that picture appear over here. And the way I believe that that's going to work, because I'm kind of under the impression I think I already know how that's going to work. We'll see if I'm wrong. We're going to shift this to the other display. So The x-axis is left and right, y is up and down. So technically, I should only actually have to modify this first value, because I don't want to modify where the graphic is up and down, but I do want to modify where it is in position from left to right. To make the graphic appear on the first display, which is off, I should just be able to put in here 61. Because that should push me all the way to the right onto the other display. So let's push that and see what it does.
Because I think that's going to do what I thought it would. Let's find out. Sketch is compiling. Because the way I think this is going to work is there's just going to be two draw statements. The first draw statement will get me the mirrored image, and then the second draw statement just gets me the one that needs to appear on the other side. It's uploading, programming, and bang. Ha ha ha! The toaster knows something after all. All right, cool. So that did in fact work exactly the way I wanted it to. So cool. That pushed our image exactly 61 pixels, because we're 0 all the way over here. Well, technically 1. Well, actually, no. Wait, what would the count be? Isn't technically 0? I guess technically, yeah, that would be pixel 0. All the way to 64. Well, I guess technically, no. Wouldn't that kind of one? Arrays start at 0. Physical, I mean, I can't have the first row technically be 0 because I'm looking at them. Oh my god, programming is hard. But that pushed me all the way off this screen onto the second one. So now, when I hold myself in a cheese wedge formation and we look at that side of the display, that's where I need the picture to be. Now the other side is going to be my nightmare because I still have to figure out how to invert the damn image. I may have to break down and just invert the image and then load it so that it's mirrored on this other side, which will again take up twice the amount of storage per face. Each face will require 2 bitmaps. And looking at how the project is going, I think that's probably where we're headed. I don't know how many faces and how much restriction that's going to cause on the code. So I suppose for functionality's sake for this evening, we'll code it that way just to make sure that that works. And then I would like to load up into the main project the all the different pieces I've written and see how much storage it takes up. If we run out of space before I put everything into the project, then that will indicate that I have to go back to the drawing board and really figure out how to mirror the damn image using code, instead of hard coding the actual file itself. So we are going to proceed here in a brief couple of minutes. I will be right back. Just give me a moment.
I have returned. Okay, all right. Let's see here. Let me get back into things. Yeah. So, the concept of mirroring this with saved storage, but I don't know if I'm gonna be able to figure it out, at least right now. You didn't invert the image. You just made it a really long one. You know what, Waffles? That's fair. Technically, you know what, to save myself on a bunch of grief on having a bunch of separate bitmaps, because if I'm gonna have to make it, separate, if I just make it like you're saying, just one really long one, that would help. If I do keep it separate though, and I do end up figuring it out though, I'll have to redraw all the bitmaps. I have to enumerate through the code either way. So you know what? I think for right now, I'm just gonna generate some mirrored images and figure that out from there. So yeah. So what we're gonna do is we're just gonna minimize our friend. And it's disappointing because this example does exactly, I'm sure, what it's supposed to. But it's very disappointing with the simple fact that yeah, see, this was the 2 rows for tiling, which mine didn't. So this example didn't really have anything that could help me because of the way that I have my matrices positioned. I don't have a second row. Mine's one long row because they're tiled left to right, not top and bottom. So with that little nightmare under my belt, I could just open this up and use this nifty piece of software to just create the mirrored versions and generate the code using the other tool we have. So let's do that. We're going to open up our documents, our mappings, and then we want I believe it's the toothy grin, I think is the one that we were working with. Yeah, this is the one. And again, I'll probably end up playing with the faces some more, but just right now I just want to get all the small pieces that we've cooked up over the last, couple of months into the main project. We can always make improvements or changes to the bitmaps. That's not hard. But to mirror this then, mirror. I know that was hard. But I'll just save this as a new image. Oh god. Alright, so I'm gonna export this. It's not technically export to images. And this is gonna be the toothy grin inverted. Mirrored. And save. Minimize that. And then we're gonna go into here. And we're gonna go to here, and then go here. And then now we've got the toothy grin and the mirrored. Which I don't know if I was supposed to mirror and rotate, or just mirror. We might need mirror and rotate. Yeah, looking at that doesn't look like it would be right. Well, let's see what it does. Worst case scenario, I keep going. So we're gonna head over to the web browser, and we're gonna head over to our image conversion tool. And I'm gonna cause myself some grief, I'm sure. It's part of the experience. I really think I have to do both, but just for giggles at this point, we're going to just see what it looks like. So we got that. the canvas size does stay the same because our offset is at 0. We have a transparent background. Yeah, I'm pretty sure I'm supposed to do both. But, meh, it's fine. Pretty sure that's supposed to be like that. And we'll generate the code. And then we're going to need to do a couple of things here. In an interest of keeping ourselves from getting too terribly lost, I did not initially change the name of the default face. But I do want to put the mirrored flavor directly below. So that I don't lose it. And then this is going to be toothy grin. I'll just do _M for mirrored, just so that's not taking up a bunch of extra clicks in memory. We'll copy that. We'll pull it over here. And then that is going to be the name of our variable. And now, to make this happen, now I purposely only messed with the one that's in the startup. I didn't mess with any of the ones here that are switching statements because I'm not worried about it right now. We're just worried about making both of these work together. And then we'll figure out the other stuff here shortly. So to make this happen, copy this, and in my head, I'm determining which way I want this to lay out, because technically we start from the left, so this is technically the first display because of the shift to just push it onto the first one that's in alignment. Nah, I think I'll still stick it on top. To be honest, it doesn't matter which one of these comes first. What matters is two things. One, that we start at 0 so that we end up on the correct display. And the other thing is that I give it the right variable name to load into memory. Now, with our offset correct here, I think that's okay. Because what I'm telling it is that the bitmap itself is 64 by 32, but for this one we just push it by exactly to the position of 61 to just shove it over. So now we're just going to run this and we'll see what we get. I think I was supposed to mirror and invert, but we'll see.
It's easy enough to fix it if it doesn't look right. We just have a couple more buttons we'll have to click. Aha, okay, alright. As I had anticipated, yeah, I had to do both. Which is fine. That's easy enough to fix. We'll just now rotate it by 180 degrees to flip the image. So then the eye will be in the correct position. Let's do that. We'll get that fixed. And then I think we'll actually be able to start working on pushing all of the different pieces of this into production and see how much space we take up.
Which is frankly very exciting. Okay, so to fix that, we're going to then, we mirrored it. Oh, I know we invert it, right? Nope, don't want to do that. Yeah. Maybe. There's potential. Yeah, because Toothy Grin 1 was with the eye over here. I think that's the way it's supposed to be. So now we will then do file. We will export. And we're going to go right over our friend here. Which now is, yeah, that would actually make sense to look like that. Okay, but now I would love it if my mouse stopped disappearing. We're gonna swoop back up. We're gonna remove that, push it again. Not worried about that right now, Firefox, thank you. And we want that one, and we want open. And I want everything else to be the same. Generate the code, push button, get the mortgage, all of those fun things. So if I do it that way, I just have to copy that. Come back over to here. I have the M for our mirrored, which technically like it's mirror and inverted, but I'm not going to be a stickler if you aren't.
I've hit the compile button. Now we just have to wait for this to finish thinking, and then we'll see what we have to work with now. So currently, that's where we're at right now. We're upside down, and that's in the middle of resetting. Now the code's pushing. Hey, look at that. That's pretty nice. That's our cheese wedge right there, folks. So now with that displayed in the head, you've got the eye top and the eye at the top, nose down bottom. That's exactly what it's supposed to look like. I think what we'll do for tonight, we're going to work through the other images, prep them, load them, and then we'll start bringing over the different parts of the code. Like I said, I don't know how much storage we'll have because this example already takes up a lot of storage as it is. And I have a lot that makes the wireless of this work. So if I run into a wall and I run out of storage, there are other ESP32 boards that have more RAM and have more storage. So if it comes down to it, I might have to replace the microcontroller with something with a little bit more heft to it. I'm hoping we won't, but I won't know until I try. So we're going to just run through our examples here, and then I also want to use the sand project. So I think I have enough time. So we're gonna work through this. It does work. Isn't it fun to watch it work? And I'm gonna be completely real with you.
Okay, I'm gonna be very real with you. The way I thought this was gonna work isn't quite exactly what I thought I was gonna be doing. Because when I first kind of conceptualized what I was gonna do tonight to make that work, I thought I was gonna have to do something different to address the fact that I've got two displays. I know that in the constructor you're telling it that it's wider just to know that there's a whole big ass display you're working with, but I didn't think that you would treat it like it was essentially two different things. The fact that we're drawing to the buffer in just 2 steps and then displaying it works fine. And it's fun because you could actually mix and match bitmaps if you do that. You could have just your face appear on just one display and then draw something completely different on the other side. So if you wanted to have only half a face, you could do that. Right now, I'm not going to, but it can be done because I can show you right now. I'm doing it in 2 steps. So that's exciting. And it would appear my camera tracking has turned off. Where are you going? We're not done. I'm not done. Where do you think you're going? Let me see here. That's this one. All right, there we go. That's the right color. I love it when things just decide to turn off when I'm in the middle of doing something. Okay. All right. Okay. All right. We're here for it. All right. First things first. Let's get the other images prepped. We'll get them converted. I'm just gonna dump them into this example, and then we'll get this one updated to have both faces. And then we could work on pulling the different pieces over to the actual production code. And then we'll incorporate the fan, controller stuff, and see where we are with storage. We're getting there! I'm so excited. I really hope I have enough storage to put the digital sand on here. I mean, frankly, I would sacrifice a face or two if I have to get that on here. And you'll see why. It's really cool. If it may not be tonight, it will be soon. But let me not get too far ahead of myself here, because we do have a lot we still have left to do. So I'm going to do file. I'm going to do open. You know what? Let me save an extra copy. So let's do save as, and then this will be the toothy grin underscore capital M for mirrored. I might as well save that, because if I do have to make additional changes to this, I won't have to regenerate all these files. So let's open up the next expression, and we'll work on the heart eye. And then we're going to do the mirror and a flip. Yeah, so it's 2 mirrors and 1 flip. That's what's going on here to make that happen. Oh, howdy gamer, welcome on in. VIT gamer, Legas. I'm making faces, gamer. What are you up to this evening? That's not the right symbol. I want an underscore. How dare. Right, we got that. And we'll do file. And export to images. And then we add our I underscore capital N. I should do W for Wumbo, but it wouldn't make any sense in this context, but it is funny. W for Wumbo, indeed. Chilling after work, that's totally fair. Well, now you got some time to hopefully relax amongst all these crazy things we tend to find ourselves in. Alright, so those are our toothy grin, and we got the heart eyes inverted, which look good. I'm just going to make all the images first, and then we'll just go from here. So we got that, and then we're going to do surprise. And then we're going to mirror, flip, and then mirror again. The faces have been going okay. So I don't entirely know how to flip the face.
I could switch back to the bench camera. That's where we're at right now. So that is successfully showing the mirror on the first daisy chain display, and the first display is then showing the original bitmap that we figured out from last time.
And instead of, I really wanted to just convert the one bitmap in memory by mirroring it and flipping it and mirroring it technically twice. That's what I'm doing right now to move the bits around, but I can't find a decent way to do that right now. So what we're doing is we're just manually generating the code that will appear in the inverted fashion. And then we're going to see how much storage we have. I'm hoping I'm not going to run out on the microcontroller, because I do have other things I do want to do, and we have existing code we do need to incorporate. So for right now, we're just going to bake up what we have, and then if I have to make adjustments, I'm hoping I've still got room, because I still want to do the animations for the mouth. Right now we don't have that. Right now we're all just static images that we can switch between. And for now, that's good enough for the time being. Ooh, watch streak. Look at you go. Awesome. Very nice, very nice. I'm gonna tell you right now, I looked everywhere. And I mean absolutely everywhere across Twitch's documentation and from different streamers. I wanted to have some kind of sound for the watch streak. It doesn't, there's no trigger for it. In sound alerts or in Streamlabs. You would think that would be natively baked in, since it seems to be like a part of the platform now. I need to make an exclamation mark command for that, because honest to God, that's awesome. I want that one. Hopefully saving myself some work by saving a copy of these. Alright, so we have 2 derpies. We have Toothy Grin, we have the hearts, and then we have Angry Face and the blue screen of death to work with. And that one's going to be a couple of different... That's technically 2-bit maps as it is right now. So that one's going to end up being 4-bit maps, because it's dealing with 2 different layers to get the colors, because there's 2 different colors. We got blue and green in that one. So as you can see, doing it this way is going to generate... it's going to generate a lot of draw calls, which is okay. It's just, it's how it is right now. Until I can kind of play this a little bit more efficiently, this is at least what we're doing. Alright, we got Toothy Grin, did the hard eye. I can make the, I do want to revisit the hard eye and make for the eye to be separate and be red instead of green, but I'm not worried about it right now. That's the thing I want to do later. Now that I know how to do different colors. That would be super cool, but again, not right now. I just want to get to where I need to be with this. So got that one, hard eye, round surprise, Toothy Grin. Angie's next. So I'm gonna be honest, I'm not super thrilled with the angry face. I do want to rework that, but that's going to be a problem for future Techie. I'm trying my best that I know that there are things I do want to change, to just leave it alone for right now. Okay, and then I do have to clean up this folder a little bit because I'm getting lost in the sauce here. Alright, we got that one, that one, that one, that one, and that one. There we go. I was gonna say, why are they not near each other? Alright, so I have the inverted version of that. Both of those, both of those. It's easier to look at this folder with those out of the way. Okay, and then I gotta do both layers of the blue screen next. So we'll do the foreground, the background, and then we'll convert all of it to code. We'll pull it over, and then we'll use the same testing structure, and then hopefully incorporate it. I hope. I'm on the right track. I hope. I'm so excited to be able to start putting the pieces together. This has been a long time coming, and it is very exciting to be able to put the damn Legos together. This isn't your average everyday Lego stream. I'll tell you right now. Can confirm these Legos are a little bit more self-assembly, if you will. Legos for tech people, exactly. See, now the thing I have to say, and gamers, if you agree with me, it sucks a lot more to step on one of these than the plastic ones. Because at least the plastic ones, the pain is immediate, and it does fade over time. These kind of Legos tend to hurt forever. Only a little bit of assembly. Oh, don't say that. Those are terrible words. We don't want those here. Yeah, if it hurts. Yeah, exactly. Alright, we got both of those. Then we gotta do the background. Open. Okay, mirror, flip, mirror. Okay, right now it saves a hell of a lot of time instead of having to manually toggle all these little dots. I am a happy guy. You want to write this in assembly? No, God, no. We don't want that. I don't want to look like this. This is what I'll look like. Do I look like I want to look like this? I don't want to look like this. No, because then we'll look like this. I don't want this. No, God, no. It's horrifying. All right, and then we got that one. All right, good. So now I have all of the inverted. Okay, and now to prepare myself somewhere to stick this stuff, there's one thing I do want to do really quick, and that's change the definition for the toothy grin from LED array. I really should have changed this before, but I'm changing it now. And again, it's an easy enough fix, and I really want it to just be something that's more meaningful. That's why we use meaningful names, and I try my best to make sure I remember to update this kind of stuff when I toy with things like this. So now we already did the toothy grin and its inverted flavor. So now we're going to put together the framework for the other inverted faces. And now that I have the names that I'm planning on using moving forward, this will be easier to add. And we'll follow the same kind of structure here. So I can then just copy it, I'll convert it and then copy it and bring all the pieces over. This is one thing you're going to notice about the way I write things, is that if I'm doing a large amount of tasks, I really do like breaking it up into separate steps. And most importantly, keeping myself consistent on what I'm actually doing. Because otherwise, I'll make a mess for myself. I don't really feel like cleaning that up. So I got that. There was a couple of them I forgot to pull the extra tab out. I'm gonna fix that now. That one's okay. That one's okay. Could have sworn there's one of them I missed. Toothy grin, round surprise. All right, we're just gonna follow in order then from the way that this is laid out. How am I? Oh my, I'm busy. I am the catalyst of the word busy. You're seeing that we're developing this live tonight because I really wanted to spend time on it and couldn't. So here we are. But it's okay. It's a productive kind of busy. It's now getting warmer and there's more things that are occurring that need to be dealt with. And boy, has that been keeping me entertained. And I'm okay with that. Keeps things interesting. Hopefully you can say you're doing okay amongst all the craziness that this world tends to offer. Cool to see the program. See, I don't know though, because I like to talk. And I have to sit here quietly when I'm reading, and I feel like I'm just leaving everybody else just kind of sitting there going, did he leave? So I'm glad that there is some interest in the this flavor of content, because I don't know, I mean, to me, rounded surprised. Yeah, see, it's upright. That's, I should just take notes out of my own book. I look at this and I wonder how entertaining this even seems to be from my own perspective. I don't know. I'm just talking. Leaves a brother to wonder. Alright, then we need the heart eye inverted. Which comes next. I'm going to tell you, when I have an opportunity, I'm replacing the stupid hand tracking sensor because it's been doing that ever since I bought this one. Because my other one died. I never had my hand whizzing up into my face constantly like that. It drives me nuts. But it's what we do. That, and then I need the BSOD face. Primary, not the background. They're all cool. I had malware outbreak stuff earlier today. Some Bitdefender logs and management, plus more new office rollout setups for clients. Oh god, no. Oh no, that's expensive. We don't want that here. Oh god. Well, it sounds like you were hella busy, to put that even lightly. So glad to hear you made it through your day okay. Because that's rough. I've dealt with that kind of stuff before in the past, and man, it'll have you thinking twice about every single thing that's wandering around through the office. Background. 100%. I figure as much. Okay, that's the background, and then angry face is the other one we have left to do. Don't get me wrong, I have no issue with taking the time to generate the code after I'm happy with, a particular face. I'm just worried about storage. I'm really hoping this isn't going to be too taxing on what we have. But the only way to find that out and then make a pivot is to try. So that's what we're doing. Okay, now that we have all of the faces over here, let's just do a quick verify. I want to see how much storage this takes up. This does not contain any of the code for the wireless connection or the motor control for the built-in fan, the onboard display. Like, there's a lot of other things that also have to fit into the project. 19% of program storage space, so I think that's going to be okay. We shall see. I was tempted to get a setup like this going for myself. Also me and a non-furry tech friend building one. Oh, you totally should. If nothing else, it is a really fun exercise to really challenge yourself to take quite literally a chunk of the unknown and just run with it. Especially if you're not terribly familiar with the different libraries and the C language as a general concept. There is a ton of documentation out there, and despite my whining, I am having a good time. It's less of whining, it's more of just I'm exasperating my words. Call it whatever I will, right? Alright, so... Exactly, learning out loud. This, what I like to refer to this as techie on verbose, okay? You know, verbose, when every single action has a verbal output. That's kind of what we're doing right now. I have no other way to describe it. That's what it feels like, though. Okay, so... I don't know why the indentation level changed on that one. High five! My other hand. There it is. Yeah, that's about right. Okay, now that we figured out for the first face, the rest of them, it's going to be a pretty simple update. The boot up before selecting a face was the default toothy grin, so that we modified it there. When we wanted to switch back to that face, using this example without the production code, I just took exactly what we drew and brought it down here. And then we're going to use that same method of shifting across our x-axis to then do the same with the other faces. And then we'll call upon our mirrored first, because that's going to be the first display in the chain. And then I say the first in the chain, technically it's the second display because it's chained off of the first one, but it's the first additional screen is position 00. Position 61 all the way to the end of 128 is the first display that's physically connected to the microcontroller. That's incredibly confusing, and I don't have a better way to express that other than that it's a little convoluted in phrasing. But to then put this into practice, we will do two things. We will add the underscore M and then have this start at 61 so that the formatting stays the same. Then we just do the rest for the other faces. We'll push the test code. We'll make sure it works. And then I think, what time is it? I'm gonna work on merging the code tonight. We'll see. We'll see. Let me just keep going. Let me talk less and work more. There are other things I need to do. Is it? Nah, I don't think I can do them. Yeah, it's fine. We're gonna worry less about that right now. We got that, and then now the blue screen of death is going to be a little different because we have two colors. The concept is the same, but we're going to have 4 drawing statements that are going to make this up. So we're going to have the mirrored base face, and then the primary face, and then we have to do the same thing for the background for the blue because it's a different color. we write all of that directly to buffer using the same trick. So it'll be the underscore M, and then shift the background by 61. And then that should line everything up. So that makes up 4 drawing statements, and then we show to make that happen. The same thing will happen when I eventually update the heart eye animation by just switching the color of the eye to being in red. We'll have 2 statements for the green and 2 statements for the red to make that happen. But I have to break that bitmap image up into 2 separate files. I'm not doing that tonight. That will come in a little bit of time. I just want to see this in action so that we confirm we have what we need. Alright, quick verify to make sure I didn't break anything. We'll push it, and then we can cycle through the options. Make sure everything looks good. I am curious to see how much power the blue screen of death is going to end up taking, though. Because right now with both displays, the toothy grin, the power supply is telling me it's pulling 1.14 amp. So it's not pulling too much power right now, but now that we have 2 panels daisy chained together, and I'm about to make both of them go very blue, we'll see how much power we pull.
Okay, so I've pushed the program. It's now going up, up, and away. The displays are going to wig out right now as it resets, because that's just what they do. Okay, cool. So I'm going to pull up the serial monitor on this device and start clicking some letters. So I'm going to go to serial monitor. I'm going to do the letter B. And that cycle will be I is okay, which is looking mighty fine. Then we got C, which is the hearts. That looks good. D is the blue screen of death. I'm curious to see how much power this is going to pull. Okay, so I screwed something up because the ending of the panel is not lit up on the right one here. I'm shifted by 1, 2, 3. I'm 3 pixels off. I think I mistyped something somewhere. Let me take a look at the Anki face. That's using half an amp of power right now. So that's fun. And then Anki was E. That's Anki. Now actually, let me take a look at something here. I think I am shifted more, so 3 pixels on that side. And I am 1, 2, 3, 4, 5, 6 pixels short. The eyes are in the correct position. Oh, they are not. Something's not shifted correctly. Let me go back to the original. Okay, so I need to shift more. I need to shift. Let's see. I need 1, 2, 3 empty. So then I need to shift 2, 3. I need to shift 1, 2. What is it? 2, 3. Let me change that value from a shift of 61 to 61. Oh, 64. Yeah. Okay, I have the shift incorrect. I thought 61 would have pushed me enough, but no, I need a full shift of 64 to put everything where it's supposed to be. So let me do the thing here. I pushed my face off the screen, but not enough.
That's okay. That's an easy enough fix. My face fell off. Oh, no. But Ash, I have my face finally working. It's exciting. But I have my shift incorrect, so I'm gonna fix that. That's the wrong scene, Techie. There we go. All right, cool. So that means to fix that, I need to go back to shifting school here and make this 64 instead of 61 on all of these adjustments. And that should fix this for everything, actually. I had the right idea, just the wrong value. Yeah, the pixel shift. Because the whole theory here is that you're writing in buffer on the x-axis push to the right to get yourself back onto the second screen. But I shifted only 61 out of 64 pixels, so yeah, I didn't shift enough. Shift more! Initial D style, you know? That's what we're doing. Alright, Ash. I promise it's not that hard to understand, okay? I got two screens. One of them is 64 pixels from the left to the right. You can count them. Count 1 through 64. And then to get to the second screen, you just start at 64 all the way up to 128, which is again just 64 more pixels. So you take a box, okay? And you just push it exactly 64 more pixels to the right. That's what we're doing. That's it. We're just pushing a box and then making something appear in the box. Okay. I think we're good now.
Yes, that's looking mighty fine. Just like that. So now, I like that derp. That's a fun image. All right, we're gonna check these over. I'm gonna get my boat back over by the bench because I'm gonna count the pixel offset. It looks correct from a distance. So I see 3 on this side and 3 on this side. So these are shifted correctly now. So now, when I cycle through these, I've got the surprised face. I've got nothing because I clicked off. Hello? Did I break it? Oh no, I'm stupid. I was selecting a screen I was already on. C is hard eyes, and then D. Oh god, that's bright. Yeah, still 50, still half an amp, but no, that's perfect. We are lit up edge to edge across both panels. God, that hurts to look at. And then we have Angie face, and the offset's correct. So now, I can pick them up. We now have our cheese wedge in such a format, and then we have the eyes in the correct positions. Now, it's a little hard to show this and hold this, you know, obviously you can see it with them being side by side, of course, but the idea there is that when you're looking at the Protogen from either side, you're going to be able to see the expressions. Such as this. So that's magical. I am so happy that I've gotten this initial step figured out. Again, it's not quite how I thought it was going to work, but I'm not complaining. Just another hurdle over. Also, I saw that cozy come in here. Oh, whoa. I'm on the wrong scene share again. Oh, whoa. The blue would blind the person on the inside and the surrounding people. No. So the blue is facing outward, okay? Everybody else is going to be blinded, okay? So the blue, the blue right now is like those HID car headlights. You're going to very much be that person. I don't have a way to turn down the brightness with this particular library, and I don't really want to rewrite it, at least not right now. So, sorry everybody else's retinas. That's I mean, to be fair, the visor itself is going to be tinted once I figure that out, so it won't necessarily be kiss your eyeballs goodbye, but it's going to be something kind of close to that. So there's that. Wondering about the visor and the glare. Well, to be fair, the glare on the inside, I don't know how strong that's going to be, but to be fair, I've never looked on the inside I've seen pictures of the inside of a suit head, of course, but what I mean is I haven't put it on to any idea of what the glare is actually going to look like. So yeah, that's a thing that's going to happen. All right, so before I do absolutely anything else, I'm gonna save this, okay? Save your work, guys. That's important.
You are correct. I won't know until I find out. And then I'll turn it on, and then I'd just be like, see, I have... Uh-oh. What? Oh. Okay, straight up, I thought that had some different sound to it. Thank you. I will save my work, Cozy. 10 for 10. Shoot, I really feel like I had that sound alert set to do something different. I wonder if they reset that on me. Either way, thank you for the save. It is... Uh-oh. Yep, I'm broken. They reset me! Oh, that's rude. Yeah, it's reset. That's not the correct sound for me. Alright, hold up. We're gonna look at this. I want to see if I can quickly fix that. That's no good. That's no good. That is less happy. What a rotten time to find out that they reset my sound alerts. Damn. Yes, this is true. I will do the hydration station. Much excellence. Let me see here, my alerts.
Bob, can I get a glass of water? Help now!
Okay, I didn't reset anything, and it's not incorrect inside of sound alerts. What? How could that be? Wait, so if I... Huh? Does this one work? Nope, that's still broken. That's cool. I am confused. What? Interesting. Did we reset my global alert settings? Ah, Eden X, welcome on in. Well, I'm in the midst of figuring this out. That's the wrong command. How dare. There we go. It helps if I type the right crap in the terminal. While I'm trying to figure this out, y'all give a follow to Axe. Axe is new to streaming. Is an absolute sweetheart. And is a hell of a storyteller. 10 for 10. So if you like stories, chill vibes, and hey, hell, more dad jokes than me, you know where to go. Texas speech is the same, or because I have a different bot for that. I'm going to do the thing. Best in browser source.
Bob, can I get a glass of water? Help now!
Okay, so if I test the alert from within the alerts, it works. But if I redeem it, that's on cooldown. Yeah, that's fair. Wait, why is it on cooldown for me? I'm the channel owner. Rude. I do have the applause set up. What is that one supposed to do? Alright, that one's correct. If I redeem that from within Twitch. It's broken. Okay, so something is clearly not hooked up, and that is going to require me to investigate that a little further. So I do apologize for the rest of this particular stream. I don't know what happened to my sound alerts. They're correct on sound alerts side, but you know what? You got a point. It does appear as if it has been unlinked. Which... Hey, me! Hey, wait, that one worked! That worked. Why did that work? Did it finally figure itself out? Of course that's still on cooldown. What about if we were to do...
Bob, can I get a glass of water?
Oh my god, it's working now. I didn't do anything! I changed literally nothing, and now it's fine. That's bullshit. I am going to take that hydrate again, though. Because, yes, that is what is happening. Okay. I'm not going to question it. That is streaming in a nutshell, folks. It doesn't always make sense. I don't get it. I think that was probably a bad API call, and then their backend finally figured it out. It must have had nothing to do with me, because it still worked, and the redeem did go through. Yeah, because even when it didn't sound right, the sound alerts bot did appear. I don't know. Bunch of goobers. Professional streamer. I don't know about that. You got streamer. I don't know about those other words. Those are letters that I don't know if I'd have them in the same order in my sentence. But takes it as he sees it. Bad things tend to happen on stream. It's a part of the gig. Things just decide they don't want to work. It's like going to the mechanic when they ask you if you've rotated your tires recently. You say, yes, of course. I rotate them every time I get in the car. That's not what that means. But that's kind of what it feels like. Wait, what? Who's doing stuff? No. Oh my god, it didn't trigger the sound. I'm going to hurt this thing. Thank you, gamer, for the tier 1 subscription. I have a whole super cool sound that triggers with that, and that doesn't work right now. I am angry. I didn't even update my OBS. Why? Why must you be so rude? Actually, I think that's actually through a different botting service. Something's broken. Ah. No, I gotta look now. Hang on. Why are we applying? It's broken. Why are we clapping? It's broken, and I'm sad. Stream in working order. No, I don't think it is. I really don't think it is. Please hold. Let's see. What is it? Alert box. And it was supposed to be the sound for the subscription. And I'm gonna play the test because we're gonna listen to it now. I want that one. That's what was supposed to happen. And it didn't. Which actually, speaking of which, now that I've gotten that test up, is the bot working? Well, the bot's working, so that's cool. Well, I'm gonna reiterate anyway. Thank you, Gamer, for the sub. Is appreciated. It truly is, because any of the money that comes towards this channel helps me to continue to just reinvest it into this to continue doing more fun stuff on stream. So, thank you. It's appreciated. I'm going to hurt my overlays though. They are doing bad. They're doing bad things. Very bad things. Oh, I'm telling you right now. Okay, this is the face of the Proto right now. I just want it to work. And I mean, it's no different than frankly any other streamer. This happens constantly. Wait, what? Did you resub again? That's not my activity feed. Or is that, oh, you know what? I bet you that's the sound alert catching up. Whatever was stuck in me signing back in fixed it. It had to have been. Because that's what it was supposed to do. It's fine. It's fine. It worked. It took a minute, but it worked. It's like a record. I had to spin around a couple times. It's fine. We did very much have to bonk the API. It sounds about right. Oh, always cool to watch in chat. Thank you. I appreciate that. I attempt with some flavor of success to put on something that's mildly entertaining, but also something that I'd like to watch. You know, just this is what we do. We do dumb stuff here, and I promptly lose my mind, which is very much what I'm doing right now. Hey, wait, what are you doing? Oh God. Oh my goodness. Axel, you coming in here with the gifted subs. Oh God. Oh boy. Okay, well, now that's testing things. Oh God. Okay, so that's level 2 hype trade. That's a thing that has just occurred. Alright, well, let's read. Oh God. What? Oh. Okay, no, that's right, because that would be the hype train alert. Oh God, alright, we're about to get a bunch of stuff in the overlay. Alright, hey, let me read. Don't run away just yet on me yet. Alright, let's see. Axe, your subs went to Sib, Porsche, Cozy, Ash, and Pine. Oh, much excellence. Mobile crashed. Oh no. Axe, thank you very much for the gifted subs. They greatly appreciated. Quite a bit, and also thank you for testing my overlay, because I don't know what his deal is with just being rooted broken. That's what do. That's what do. Okay. All right. I'm gonna attempt some stuff. Oh God, it's still going. Axe, I'm almost positive you're the first person to trigger any of my notifications this back to back. I don't think I've ever actually witnessed this before, so it's interesting to see that it does trigger per gift sub. That's interesting. Need to figure this out soon. That's totally fair, Axe. I mean, Axe, by all means, if you need help, you know where to find me. You've done a fine job with getting yourself just into the platform with how many things that have to be configured to make that happen. All right, I'm gonna keep going. We gotta keep going. I do not have a lot of time left here, so we're gonna attempt some stuff here. Since I already have the displays hooked up, let's see if we can just incorporate this. So we're done with that for right now. I don't need that open anymore right now. That's good right now. I think I saved this one already. Wait, wait, I'm saving something. No. Oh God, hang on. No, I did save this already. All right, good. So I click the save button. Save. I don't you run. I hate it when my overlay runs away on me. Yes, I am positive I want to exit. What are we doing over here? Like yes. Gamer, thank you very much for the gifted sub. That wandered off to Seeking McGee's Bash. Okay, that's it. That is quite the username. Tis appreciated. Very, very much so. Gift one to get you a level up. Oh, fancy that. Damn. Okay. We are now at level 3 of a hype train. Hot damn. I think that if you do participate in that it gives you some kind of emote, like that's just like randomly selected on the platform. I don't know how this works. This doesn't happen to me. I appreciate the gift sub, but we're triggering things I never see, so I don't know how they work. Oh, that's fine. That's exciting. Well, actually see things actually work on the overlay. That's very nice. All right. Yes, we're doing the thing. We are doing the thing. Oh my god, that is adorable. What? Personal best. Twitch hype train. Interesting. Okay, so that's the gig. Oh, that's cool. All right. I like that. That's cute. God damn. All right. We're going to make some stuff happen here. Hopefully. So we're going to go back to here. We're going to scoot down to here. And we're going into the folder that's a little scary. The prod folder. I specifically keep the production code separate than all the tinkering codes so I don't lose track of who goes where. But now we're going to merge some code because we know this works and we're going to bring it over. Let's not reboot the toaster, please. Okay, I got a lot of faces and trying to avoid this one. I need my visor to work. Just a little bit. Just a little bit. As my hand clearly wants to just keep gluing itself to my visor. You know, I need to be able to see the terminal. All right, we're doing this. We're 100% doing this. I can tell you that the management screen that's going to be on the inside of the head, I'm planning on building that menu out once it's finished to also to be on the controller side as well, so that you as a suitor, if you're looking to use this code, you can just plug in an I2C display and then hand your controller over to someone else that may want to adjust your faces in real time while you're interacting with someone, so that you on the inside will be able to watch the faces change on your behalf while they're holding your controller, and both of you can know where things are. Since the controller is wireless and can handle quite the distance, that could really open up the possibilities for placement, because you're not hard-coded, or excuse me, not hard-coded, not hardwired. Yeah, this screen main data peer. This is the big guns. We're breaking out this one. Now we are going to build out a separate import file for this that will live in that folder. So we'll do our faces. It is incredibly important to remember the .h or bad things will happen. And now it made that in here, and now all I gotta do is literally just copy everything in here, line for line, and bring it over to the other project. So that's the first part done. We have a hype chest. I'm spiraling emote. Okay, that's fair. Oh god, that's fun. Thank you for participating in the hype train and humoring me on this channel. It is, again, greatly appreciated to y'all. I do have fun showing and telling in all this insanity. Thanks for sticking around. Okay, so I gotta get my bearings here. So I brought over the faces. The next thing I need to do is I need to tell it that we have a separate file, which all I have to do is just bring this include statement, because I kept it exactly the same, and shoot that to the top here. So that will include the external file to keep the code from getting too messy. Now the next thing I have to locate here is the action events for the menu. Now, been a while since I've looked at this code. This is why I didn't want the code to sit for too long, because I gotta remember how this works. Now we do have to bring over the actual events, like the stuff that makes the fan work. We're gonna come back to that. I'm probably not gonna have time for that for tonight, but I do want to incorporate the faces. I really would like to get that working. So what we're gonna do next, because right now it's based on the action events. That's what we're worried about. Because the action event is just going to be doing the different drawings. Now, I do have to include...
Bob, can I get a glass of water?
Thank you. I am drinking hot English tea this evening. What do you all have brought to the table? Do we have water, soda, coffee? I hope none of you have energy drinks, because that's just a really fast way to be tired. I'm still tired, but now I'm fast. That's but the best way to describe what those things are all about. Coffee and water, that's a good combination. All right, so we have our library definition that we're going to bring over. By all means, please enjoy the lurk, and thank you for dropping by, gamer. Enjoy the rest of your evening. Okay, so I'm going to leave myself a comment that the Adafruit Proto Matter is for the two larger displays. Now I do have to bring over my pin definitions. So I guess let's do that. Let's bring over some of the basics here. So I need to bring over all of this that happens before the void setup, which I suppose I could just wedge that right here, which is totally fine. That all stays exactly the same. I don't have to initialize the controller because it will be already. And then I need to check to make sure that this is started. So inside of void setup, we will initialize the object. So we'll scoot down to the setup section. I feel like I've scrolled past it. Did I scroll past it? Nope, I did not yet. Alright, so we have the Wi-Fi. We'll get the Wi-Fi connected. And then we'll go through starting a wireless connection. There's our loop, and that is the end of setup, right? Right there. Yes, that's the end of setup. So then... so I'm just going to stitch onto the bottom the initialization of the big screens. So we should see nothing on the big screens until we've connected to our controller. That will initialize the little display and then initialize the big displays. Now right now, just simply initializing the displays won't show anything on them. So to start us with a default face, we would need these two statements to stick in the startup area. And I think we'll do that. The toothy grin I feel like is a good default. I don't need that comment in there. We know that we need to, you know, actually do the thing. So that when it boots before we even touch the controller, we're showing something on the outside. Alright, so we've got that. And then inside of our void loop, we were just looking for keyboard input. Now we have a whole digital menu we've built out. So what we're going to need now is to build out this switching statement based off of the driving factor of the menu. So the logic gets to stay the same, but what we end up actually using as case statements is probably going to be a little different. So that's the part we got to figure out next. So right now we've got our main void loop, which I think what we need to build will have to go above this area. This does the navigation of the buttons based on the sensor data. And then for testing purposes, we have the serial statements that spit out to the terminal, which we could leave alone for right now. So yeah, this is just refreshing the internal screen. So I gotta scoot back up in the code here. And what we need to find is the hardware event for the menu for the faces. So we can see right now that we have an enter event called set face, which is awesome. And what that does right now, this is what I was looking for. It's a void function. So what our menu is going to have to be built in this section of the code. It's going to take our temporary face selection, which as you cycle up and down through the menu, what's going to end up happening is there's going to be that temporary value, and then once you confirm it by clicking the enter key on the controller, that will then become the confirmed face. So we don't want to update the external faces until we've confirmed what we want. So I'm not going to change that, but what we do have is that we've got in this action the confirmed face. So I should just be able to take that switching statement block and then set the switch to this variable of confirmed face. I believe we could get away with doing it that way. So we're going to take our sample code, which starts here and scoots down to here. Right now, this area here of reading it from the keyboard we don't need, and we're not worried about serial availability because we're using the menu to go through this switching statement. So this block of code is only going to run after we've clicked confirm, and then it'll cycle and then run through the displays and hopefully make the change to match what we've selected. So I'm going to copy our block of examples, and then underneath here I'm going to leave myself a comment, end of set base void block, just so I can keep track of where that brace ends, because this is about to get large. Now, the way I had the menu currently drawn, I did letters instead of numbers. Now, I believe with the switching statement, I can use numbers, but I have to be careful with that. Because these are char values. Now, confirm faced is an int. So I believe as long as I get rid of the single quotes around these, that'll be okay. I might fight a little bit of the compiler here on this. But right now I've got an idle face, which is 0. I don't have a happy. So I'm gonna have to change the flavor text on these, but that should be okay. Because this is what makes up the menu. So we have temp face, faces menu. So idle I'll keep the same. And actually, we could just call it Toothy Grin for now. That more accurately describes what we're displaying. So instead of an idle face, we've got a Toothy Grin. And I'm gonna stick with the numbers instead of letters, because I think I can change this to match the casing. So case 0 will be the Toothy Grin. So Toothy Grin, case 0, and then we need to pass confirmed face into the switching statement. So we've clicked the enter key. Temporary face number has been set to the confirmed face. It's an integer. We have a switching statement that's now going to switch based on that case and pass to 0. And then we're going to update the big displays that everybody gets to see on the color matrix. So now I just have to update the rest of the menu options, click the validate button, cross my fingers, push the code, and fire up the other controller, see what happens. I actually think I have to grab my breadboard because I don't have the little display hooked up. I'll have to do that. So then the next one in line was supposed to be the surprised face. So then we'll do surprised. And surprised is going to be event 1. And then we have the heart eye. And that's going to be condition number 2. I do have an angry, but that's not next. Next in line was the blue screen, so we have the BSOD face. That's going to be option number 3. And then we have Angie face, which is the 4th case. That's going to be option number 4. And then our default is to do nothing. I should be okay to leave that in there. Because since we're working out of a structurally driven menu, there's never going to be an instance where we would get a value that's outside of this menu structure. I suppose the only time that could happen is if I somehow wrote too far out of memory, accidentally writing into the field unintentionally. All right, we're going to validate now, and I'm going to pray that I didn't screw up anything along the way here. I think I can get away with doing what I did, though, to that switching statement, from switching it from chars into integers. We'll see if it bitches at me. I might have to look at the syntax for that. But I think I'm going to be okay. I hope I'm going to be okay. The patience is killing me. Come on. I know I just like added a whole bunch of additional stuff to this, so it's gonna take a while to do this compile. But that doesn't make me like, man, you can do it. I believe in you. Please. Oh, come on. You can do it. Okay. Okay. All right, cool. So we are looking amazing. I still have to fit in the library for the fan, but we're only at 48% memory. That's more, that we have a lot more left than I thought we would right now. So I'm gonna push it, and then I gotta power it off and plug in the internal display to make sure everything looks correct. So let's push it. I am not using nearly as much RAM as I thought I would. Which is great, because RAM is so goddamn expensive. It's using all of the memory all of the time. So it's unbelievably expensive. It's very frustrating. Now, once this pushes, I fully anticipate to see absolutely nothing on any of the displays until the controller connects, from the way that this is currently laid out, because the project is designed to pause until the partner's attached. So I have to fish that out of the box. That's okay, it's right here. Like I said, I gotta plug in the little, why did bad things happen? Gonna open port 6, file not found. Okay. I might need to close the other project. We'll see here in a minute. Yeah, it just wigged out. Oh, no, don't do that. Something went wrong. The device which does not exist was specified. This error originates from PY serial. It's likely not a problem with ESP tool, but with the hardware connection. So, first thing I'm gonna do is I'm gonna go to this project. I'm going to close it. And then I'm gonna go to tools. I'm gonna go to the comm section. Ah, it switched ports. That'll do it. If that doesn't fix it, I might have to reboot that laptop, but that's okay. It's not going to interrupt us. We just might have to wait a second while it restarts. I'm a little cautious about opening up multiple sketches and tying it to the hardware at the same time, because of it does weird things with the COM ports on the device. Windows 11 is not exactly known to be a stable operating system, so I try not to screw around with that too much if I can help it. There we go, that's all it needed. I just need to reselect the COM port. Alright, so even right now the displays are turned off, which is fine. Oh, okay. I'm not gonna lie. I thought that was gonna take longer to program. Interesting. So I'm not gonna lie. I'm seeing faces on the bench right now, and I didn't think I would until I had the partner connected. But if we go to the serial monitor, currently I have nothing. Actually, I don't think I have anything that's supposed to appear down there. All right, that's fine. Let me get the other hardware hooked up. I'll switch cameras so you can see what I'm up to. And then we'll fire it up and see what happens.
Now, I know I did put inside of the startup code for it to choose that face. I just didn't think, I was almost positive that it wasn't going to show anything until I had connected the neighboring controller. But again, I'm not bothered. It's just an initial idea, which did not appear to be correct. So, shoot. Okay, I made a small mistake, but that's okay. I have these hardware defined based on MAC address. My camera turned off again. Damn it. Why it keeps doing that? All right, let's try that now. Is the camera working again? It is working again. Okay, cool. So, that board is supposed to be the one for the controller. This is supposed to be the one that's supposed to be connected to these. And the way I have this hardware defined, I do have to reprogram for this one to be that. And to put the controller code back on that, it'll only take me a minute. I gotta switch them. And to be honest, I don't really remember. I must have just mixed them up, which is fine, and I'm kind of grateful I left the screen attached, because that's certainly important, but that's okay. So first things first, let me load the correct code on this before I disconnect it. So I'm just going to open up the other production sketch, which makes up the controller side. I'm gonna push that. The faces are gonna disappear, but that's okay. That's only gonna be brief until I have them programmed in the correct orientation. And then I've got my controller and breakout board. So we'll get this all hooked up, and then we'll switch some faces around, and then I should have enough time for us to incorporate the code for the fan, and then we'll see what kind of code we've, how much storage we're using, because that's at least one other library I'm going to have to include. So let's see here. So we've got this side. So I'm going to upload that. That's going to completely blow away the faces on this and change all that, but that's okay. That's only going to be momentary so that I can put the correct code on the correct board. So maybe that's okay. Actually, wait, now I'm not sure. Did I actually do that? I may be incorrect. Am I incorrect? I think I'm. Hang on. I think I'm incorrect. Let me cancel that. I don't remember. No, this was supposed to be the one because it's got the header soldered onto it. I must have been screwing around here. All right, hang on. Easy way to test this before I potentially make a mistake. I'm going to remove power. And then I'm going to connect Tiny Display to the project. And we're I want to see what happens. Because if I do have this programmed correctly, we will see stuff on here. Okay, so I got that connected there. I got that connected there. Be careful not to accidentally short anything out here. And I'm going to plug the cable back in to get power. Bam. And that should boot all that back up. Oh, that's right, I forgot. For some reason, I have to still figure out what's going on here. I have to reset the connection to the big displays, or it doesn't turn on. I'm not entirely sure why it does that either. Okay, so all right, so looking at this, we have nothing here, but that's how it behaved before without the other board that runs the controller. So let me apply some power to this and see if we get menu. Well, I haven't changed anything on the menu side, and all this does is just send menu information, or the coordinate information to the first project. So even though I changed the menu layout, this particular board right now knows nothing of the menu. So I should just be able to power this on, and if everything else is correct, should take a brief moment. We should get a picture. Which does not appear to be happening. Which could very well mean that I have accidentally erased what I had on the controller for the other one here. So, easy fix. I'm just going to reprogram it. So I'm going to disconnect that so accidentally overwrite it. And then we'll push the code on it. That's the trouble of having this kind of a project sit for a period of time on the bench, is that it's easy to forget where you left, like what state you left stuff in. And this is no exception. So now that I have that connected, I'm now going to push the production code up to the microcontroller. And the idea here is that this has an additional connector head that's open, so you could just daisy chain the other wire for another one of these displays to be on the controller side. So it should be pretty easy to actually incorporate that. Okay, if I don't break anything else here. A fatal error occurred, could not open COM4. That's because it's not on COM4 anymore. Yeah, that will happen. That'll happen. I need to select the right input before fixing the sketch. Yes, because I'm a silly toaster. All right, compiling, and we go again. Unlurk, you has returned. Much excellence. So +2 to drinks. Oh my, okay. Well, gamer, you have returned. We are now in the midst of testing our code, and I realized that I had overwritten the code that runs the controller, which I have here. So I'm fixing that before we test everything else, because I kind of need that for everything else to work. Okay, so we did a hard reset on that. So now I can unplug you. And I can unplug you. And then I can re-plug in you. Okay, so we got that. That booted up okay. And now, through the power of friendship in this cool rock I found, known as an ESP32, I'm gonna put some more power into this, and hopefully we'll have something useful. I hope. Yes, okay, good. Small problem I'm gonna have to accommodate for. On the menu, the word toothy grin runs off the screen, but that's okay. So I'm gonna click confirm, go into the menu, I'm gonna go down to heart eyes and click confirm. It works! It works! Oh, it works! Oh god, it works! Oh, that's so exciting! Oh my god! All right, we get these kind of more in frame here. It does the thing. It does the thing so well. Oh god! All right, good. So we got that, and then I can hit the Z. That turns the display on and off internally. So that's dope. I'm gonna go to surprised. And then I'm going to go down to BSOD. Yep, that hurts to look at directly. Nice, nailed it. That hurts my eyeballs. And then we've got Anky Face. And then I could scoop back up to Toothy Grin. And there we are. So to finish incorporating the fan stuff, we then have to update the code with that. So we're going to do that, and then I think we're going to call it after that because it's getting kind of late. Oh my god, it works. I am wirelessly doing the thing. I say wirelessly with all of these wires, but you know what I mean. Oh my god, it works. It works. It does the thing. I can't believe it does the thing. I mean, I know. I mean, I've been testing all up until this point, but still, even then, watching it in action's amazing. Bird.
It does the thing. It does the thing. It does the thing. Ah! I'm so stoked. All right, cool. So the same logic's going to apply for the fan. So we're going to incorporate that now. My God, the ultimate programmer and tech person. It works. No, hold on. I am not the ultimate programmer. Okay, I'm a guy who does this in his spare time. Okay, but it works. You can't imagine the excitement on the inside. I'm jumping up and down. My gosh. Okay, all right, yeah, so really quickly I did have to re-upload the controller code. But again, once I am happy with the menu, I'm going to incorporate it into here so that anyone can plug in an additional display and be able to do the thing. But again, that's not right now, that comes later. So I can close that because we don't need that open no more. Big stuff.
You got this, Tech.
Thank you. I'm trying so damn hard. I actually got to do something. Oh, it's so exciting. I am going to get the fan temporarily wired up on the bench though once we bring the code over. So without further ado, let's do it. Let's do it. I'm so down for it. All right, I got to open that other sketch. We're going to go back out to experimental. And then we're going to do the ESP32 fan controller. This is what we have to incorporate over. A couple of small things that we'll have to clean up here. It's exactly the same principle. So let's see here. So I have to declare the PWM pin, which we used. Ignore what's happening. Actually, my ears are in the way. There's sensor data. That's... Why are we seeing sensor data? We're going to ignore that. I guess I do have some statements that do still write. Okay, it's all right. It still reads back sensor information. I'm gonna move this so that you can see what I'm talking about here. When you open up the serial monitor and you choose the same COM port for the same board across multiple windows, as you'll see here, over here and over here, it's just what it's dumping to the terminal. It has nothing to do with what we have up above. But okay, all right, we're gonna do the thing. We're gonna do the thing right now. I have been wanting to do this for so long. Oh god, I'm so here for this. All right, so we have pin number 3. We're gonna bring that over. Actually, let's just bring all of this over. I need all of these things. Those all happen above the setup. So I'm gonna scoot back up here. And then I'm gonna put that. All right, I'm gonna wedge that in here. So this is gonna be code needed for the fan. controller. All right, so we have our pin. So pin 3 will still be our PWM pin. And then we set our frequency. It's an 8-bit resolution, which means that we're still working with values between 0 and 255. So we're gonna have to make some slight adjustments to which values the menu dumps to us. But again, it should still be okay. So that's fine as it is. That's right, I forgot. So doing it with an ESP32, there's no additional library required. It's just a write command. I forgot about that. So to explain myself a little bit here, when you do this kind of work on a Arduino or the Hero board, let me rephrase, the Hero board or one of those smaller microcontrollers with way less RAM and others of like, you have to include a library and adjust the manual timings of the microcontroller. You do not do any of that with an ESP32. It's very simple code that makes this part work. It doesn't require any fancy stuff because what's built into the default library is all that you need. So without further ado, we do need to bring a couple of these things over. So we need to configure the latch object. So we need that. We need to turn the fan off when we first start so we don't, send ourselves to the moon. So I'm going to copy that, and that goes inside a void setup. So we're going to go back over here, and then I'm just going to jump to it using void setup, and then I'm going to scoot down a little bit here. Oh, too much. We have that. Priority. Alright, there are our initial faces. And then underneath that, I'm going to put the comments for needed for fan controller. Okay, and I'm going to indent the comments so it's on the same line level. Okay, so needed for the fan controller, we're going to add extra space in there. We set our PWM pin, which is 3, and then we set the frequency, which is 2500, and the resolution is the style of variable we're working with, or the different options. So between 0 and 100 is mapped to 0 and 255. These fans do not work well below 30%, so we're going to choose a couple of values that are above that. So with that, the next thing that has to happen is we're going to swing back over to here, and I'm going to ignore that. And literally the same exact thing I just did for the other working example, I'm going to do to this one. This is everything we need to make this other one work. So now we're going to run over to the fan function. So we got that's the print line. I'm in the wrong area. I gotta scroll back up. So that's confirmed case. And then let's see here, we've got temp phase, confirmed phase. We're below that. Here it is. There is the void function. It's called set fan. So literally exactly the same way we just did it for the faces, we're going to do the same thing for the fan menu. So I'm going to add an extra space in here. I'm going to paste the code in. And then I'm going to take our confirmed fan speed, and that is what we're going to switch against. And then we're going to change these case chars into integers, because our variable is going to be anywhere between 0 and 255. Now, you have to be careful, because when you're working with integers instead of chars, I believe that no, I think, never mind. Might not be an exact match thing. I would never mix and match. I would always go ascending or descending. I would never mix and match by, like, what I mean by doing, like, 50, 60, 100, 70, like going all over the place. I would do, 10, 20, 30, 40, or the other way, 100, 50, 40, that kind of thing. It's easier to read, but also, most importantly, some compilers struggle if those type of options in a switching statement are not in ascending or descending order. I can tell you for a fact that if any of you use Microsoft's Excel with the VLOOKUP function that does enumerate through lists, if it's not in ascending order, it breaks. It doesn't work at all. It doesn't return the right values. It'll give you something, but it's not the right thing. So just knowing that from my days of spending time with Microsoft, I'm in the same habit here. Okay, so we're gonna do the same thing. So I'm gonna scoot down here, and I have maximum power being 255, because that's max value. So that's gonna, instead of being A, that's gonna be 255. And then I have to be careful that I declared this object somewhere. Let me make sure I declared that up here. I'm almost positive that I did. Yeah, it's right there. Good, and it's an integer. Integers can handle numbers that large, so we're okay. Case B will be half power. And then our, I skipped the value, 69%. I'm still gonna keep that. That's just kind of fun. That's not a half power is 128, but 69 is higher than half power. My menus are drawn in reverse, but it's okay as long as I build the menu structure correctly. It'll still work. So yeah, our off is 0. Half power is 128. 69% is going to be 5 times like 175. So we'll do that next here. So we'll do we'll do 176. I'll round up. So 176 is going to be here. Then half power is 128, which will come after that. Okay. And then we've got what's after that? We've got maximum power, 69 half, off. So off will be off. So we have 0, 128, 176, 255. 0, 128, 176, 255. Okay, I should have all those mapped correctly. One more thing I do need to include in here is to actually send that value to the fan. So that initial speed that I had set from the example code. I then have to call the write over here. Now, I want to include that outside of that, so that is going to occur there. So then I take my PWM pin, which will be pin number 3. I pass it the fan speed, and then that should be the end of the story. I should be able to hook up the fan and then use the controller to enumerate through the face menu and through the fan menu. It should start from off because I did set the variable to 0. So without a further ado, I think I have that one hooked up, right? I've got... Yeah, okay. Let me push the code. I will have to temporarily shut that off. But let's push it. I'll update the code. And then I'll grab out the alligator clips. We'll hook the fan up to the bench, and we'll see what kind of power we're pulling. I hit Control S before I hit compile, but thank you. Okay. We're back in our parked state. So I'm going to switch to the camera. We're going to wire up the fan, and we're going to just make sure that works.
I'm so excited. I really didn't think I'd have the time to work on this tonight, but honestly, it just worked out. Very exciting. Okay, so now I've got a hell of a mess on my hands over here. I am incorporating all of these little damn things. Alright, so we've got... so this is going to be a challenge. I've got... How the heck did I do this before? Are these female connectors? These are the female connectors. That would explain how I did it before. Okay, so... I need to take... First things first, I'm going to remove power from everything that's on the bench right now, so I don't accidentally fry something, because I do have to move some wires around. I need to supply positive and negative power. So we're going to do the red line and the ground line. I take up residence inside this alligator clip. Alright, so that's the positive. I'm going to hold off on the ground right now. I'm still working on getting the rest of this stuff hooked up here. And then on this microcontroller, I need to connect the white wire to pin number 3. Let's transmit, receive, A1, A2, A3. It's going to be that one right there. So we've got our connection to the PWM pin line, and then we need our ground connection between the fan, the displays, I should be able to get away without using the alligator clips. And then I'm gonna plug our stuff back in. That's right, I keep forgetting. I don't understand what's causing this from booting. I do have to look into this. And then, but because the board, because right now the board does forget who it's paired to, because I haven't figured that portion out. I'm just gonna have to tap the reset button on the controller side to restart it. Once we see the menu, now the boards are booted to each other. So then now I'm going to go down to fan speed, and let's choose half power. And something is probably loose. I chose half power and nothing is happening. I have connection here. I have connection here. Are these fully seated? They may not be. Goes the white wire. I'm on input 3. I feel like I'm on the wrong line. Yeah, 404, yeah, you're telling me. Well, just to check real quick, I don't believe I messed up anything with this, right? So I can, yeah, I can still cycle through the faces okay. Yep, the fan is quiet, which means I have something incorrect here. Could very well be that something is just loose. Like, stupid loose. I don't like how loose that is. I still didn't rework this connector because I'm still learning the tool. I don't like that I have this set to full power right now. If it jumps to life, I'm gonna end up getting sent to the moon. Alright, let me take a look. We've got our write command that runs at the end of the event. I'm passing it PWM pin number 3. Oh shoot, I might not be using the right definition for that. Let me take a look at the data sheet. I almost feel like I've used the wrong one. Like, I could be plugged into there because I had read from the data sheet that that's permittable to be used as a PWM pin, but something tells me that I did not call it correctly. I thought I had done before, but clearly it's not spinning, so it's clearly not working. This is not good. Where did I put my data sheet? I need my data sheet. Otherwise, I can't fix the problem. Where the hell did I put it? Oh, there they are. Aha! Alright, now I need the correct data sheets. That's the other problem. Let's see here. So I want that one. I need this one for the Portal S3. Yep, that's definitely the problem. GPIO 3 is A1. I have it plugged into A3. So I had the right idea. I am physically connected to the wrong header. So simple fix. I'm going to set the fan speed from maximum back to 0. I'll move the pin. Okay, that's where I'm supposed to be, on A1. I'm gonna have to update my notes in the code, but now, fan speed, half power. Yeah, baby. Yeah, baby. It's working. It's so loud. Maximum power. Surprise face. It works. It actually, honest to God, works. That's interesting. The fan goes slower when I choose it because of the amp draw. How cool is that? It works. They both work at the same time. Shoot, I forgot to pay it. I hang on. I forgot to check to see what I wanted to see what the amp draw was. So BSOD face, maximum power. I am sitting at about an amp and a half. That's hella cool. Yes, and I think in part that the BSOD face is causing the slight reduction in fan speed because of the way that this variable power supply puts out its amperage. It's capable of putting out 30 amps, so I think it's okay for when it's going to get wired in. I could say it doesn't slow it down much, but you can audibly hear it. Oh, that's cool. Oh, that's super cool. I'm loving this.
Loving it. I'm loving it. It works. I'm gonna save my work again. Control S. Yay! Okay, so, yes, you do ask an excellent question, to which I was just about to address. You read my mind, because this ain't gonna work off a no stinking power bank, I'll tell you that right now. Building the battery, and most likely the BMS management system is gonna be next. And then, to get the wiring from its squid looking setup right now to something that's a little bit more permanent, that's gonna have to kind of get figured out as it gets put together. Oh, absolutely, 18650 cell time, yeah. So I don't know if I'm gonna go that route just yet. I'm thinking about potentially using the RC batteries, the lithium ion chunky cells, because I think I can get my hands on a couple of those with a really high output without having to go through the process of building the battery myself. I will if I have to. I specifically paid the money for a battery welder for that purpose. I have the tool. I do have to get my hands on the nickel strips and a couple other things. But we'll see. I have to do a little bit more research, and I have to get some I have to do some math to determine how long I want for a runtime. But it looks like at maximum draw at 3.7 volts, I'm pulling just about an amp and a half. And that was with both displays on full brightness with a combination of green and all blue, which is a very, very intense color. So, can confirm. Super stoked. Oh, let me add a comment real quick for that pin definition that needs to be plugged into A1. That is super important. I do not want to forget that again. That's why I looked at the data sheet, because I could not remember. Let me fix it first and I'll save it. Yeah, PWM pin in this comment. I don't know what that's old code. So it's going to be A1 header on the portal S3 port, because that is where I don't need to send that code. It's a comment that doesn't go into the compiler anyway. But it's saved. It's saved in the code to remind me for next time when I go to plug this in. It's day one header. But yeah, that oh, that's so exciting. Ah, it's so good. It's so good it works. Oh, that's so good. It's so good. I don't know where do my shoulders go? What am I doing? Why am I turned? Oh dear. But I'm over here. There we go. That's better. Goofy thing. Ah, that's magical. Well, we've been at this for 3 hours. We figured out the screen invert. We got both faces. We've incorporated the faces into the primary production code. We've incorporated the fan controller into the primary code. And we've tested it. And it works. How exciting. So, there's a couple other things that we're going to have to do. I do not have the time for it this evening. But a little bit of a spoiler for the next time we work on
this. I do have some of these USB amp tools so that we can figure out how much the microcontrollers themselves are pulling, because we're going to have to use some math to figure out how much amperage both microcontrollers, both screens, and the fan all use to figure out our battery capacity.
So that's all going to be a part of the next conversation with the proto build. Once we figure that out, we'll have to buy the supplies, build the battery, and then we get to work on choosing filament color, printing the base, and then working on assembly. I'm gonna have to do a little bit more research on the actual visor portion that has to be tinted and formed, but that's on the horizon. That's gonna be a part of this whole crazy thing we're up to. Oh, absolutely, the technology is magic, and it's even more magic when you build something and it actually works. I plan on incorporating the microphone into the project, and the ability to add like mouth animations and things of that nature will come later. Oh, real quick, while I'm still on the topic, I'm gonna click verify again. I want to see how much space this is taking up on the microcontroller, because it will tell us here in a second, so we can get some statistics real quick. I still want to add the digital sand as a face option to this. That will get incorporated. I'm not forgetting that because that is super cool and I want it. Okay, so we're still at 48 bytes of program storage after incorporating the fan. I thought that was going to be okay because it's using the default library stuff, but I wanted to see that. So we're at 48% of program storage, 21% of the dynamic memory. We have loads of RAM that's left, and we have a decent amount of storage left. So we have the ability to add more faces. The digital sand we're going to be able to incorporate, and that should leave us room for some more animations so that we can incorporate the microphone and cause the mouth to move, so that we can quickly cycle between the bitmap files to make motion. I don't think eye tracking is going to be a part of this. That's a little heavier and outside of the scope of what I feel like I'm capable of a first build proto. I would love to incorporate something fun like that, but that might be something, well out into the future, because I know that even when I'm done working on this first build, I'm not going to be done working on like the proto in general. I'm going to have other things I'm going to want to do with it, but I also have other projects that I do want to move on to. So the proto is never going to fully go away. I'm still going to be tinkering with it on and off even after I get to the point that I'm quote unquote, done with it. It's never going to be done. But I do have some other things that are in the back of my head that I do want to do. And we picked up some really cool skills working on this thus far. And we have hit a serious milestone tonight with all the little pieces kind of wedged together now finally. So excited doesn't even begin to describe the feeling. But that's okay. So for the next go around, I am going to be quite busy over the next couple of weeks. So I don't quite know when I'm going to be live again. I can tell you it is going to be on a Wednesday, like my normal schedule. If I have the chance to do an off schedule day in the next 2 weeks, I will. So if you find me at a random time, feel free to drop by. But my next structured stream, I don't know if we'll be back in time. I may be live on the 25th. I don't know. If I am, it will be a game, because I don't think I'm going to have enough time to put together what I need. I actually have to prep first to talk about battery math. That I can't just do by the seat of my pants. And the 1st of April, I don't think I'll be around. So, nor here nor there. Yeah, no, thank you, gamer. I'm thrilled to have done this. Like, I did this. I'm so excited that I got to do this. I have had the interest in doing microcontroller work for as long as I've been in the computer space. But I have to kick myself a little bit because I knew I was capable of learning it. I just never decided to sit down and get my hands on some of this stuff. Microcontrollers aren't particularly overly expensive. Everything in this world has gotten more and more expensive, but these are one of those pieces of electronics that the tools to, do more than just plug in a serial cable gets a little pricey. But I never actually sat down to actually learn it, and I cannot express how excited I am to have finally taken the plunge into it. The 30 Days in Space franchise that springboarded me into this, and then now actually making something that's unique to me and the channel. I'm really happy about it. So it's been a really cool journey so far, and I am looking forward to seeing this to the end. Because I know that I'm not going to have the head built for the upcoming convention I would have loved to have bring it to. I can tell you that the side plates that are on the side of my head, I do want to incorporate these as lights into the proto head. And the way I'm thinking that that's going to go is that we're going to build the actual head and just leave the wiring for that in the sides of the head, and then those plates will be added later. Because in addition to wanting to, build them, I want that to be something that we design, send the manufacturer, and install into the head. Let me try to remember the actual name of the application, because it's let me just see my desktop icons. Let's see what the name of the thing's called. Easy EDA Pro is the name of the application. It doesn't cost anything royalty-wise, because the tool is specifically for telling this specific company your layout for your electronics. You send them your design in what's called a Gerber file, and then from there they produce your boards. If you want them to assemble them for you, you can pay for that service. Otherwise, you could pay for just the boards and assemble them yourself. So I want that to be a part of something we do on the channel. But I can tell you right now that I am up to my neck in just building the base of the proto. Still have to learn the sewing, the furring, and all the other things that go into that. So these are going to be coming as a future update to the head. But we're going to just get the head built first, and then we get to add the cool lights to the side. That's another thing that I do want to add to this. But the whole build is being done in modular pieces, so that we can proceed to just work through each chunk and just build off of that. And I can't tell you for a fact, I'm backing up the software and the code on that laptop tonight when we're done here. I don't want to have to do that more than once. I already figured it out. I don't have to figure it out again. So yeah. So that is where we are going to leave that for this evening.